Hello students, I hope all of you will be fine. So this is our lecture on DeltaStar circuits, that how to solve or find the required quantities in a circuit which are neither in series or nor in parallel configuration. So this is one of the circuits like those configurations, because here you can see that here 100 ohm, 125 ohm, these are neither in series nor in parallel, because the two ends are neither connected to each other nor in series with each other. So what we have to do, we have to find the current and power supplied by the 40 volt source in the circuit shown here in this figure. So what we have to do, first of all, we have to find the equivalent resistance, and after finding the equivalent resistance, we have to go towards the current and then power supplied by the circuit. So in first step, what we have to do, this is our circuit here. So in this circuit, this one is, these are our resistors which are given. Okay, this one, okay, these are our resistors. So this is 5 ohm, this is 100 ohm, this is 125 ohm, this is 25, this is 37.5, and similarly 40, and these are connected with a 40 volt source. So in order to find the equivalent resistance, we have to convert any of these two deltas. These two are basically the delta circuits, and converting any of these delta circuits into star configuration will basically make this circuit easier to solve. So let me change the color, and let's say we want to change this delta circuit into the star circuit, because now here you can see that this one and these two are basically the delta circuits. So in order to convert them, in order to convert them into the delta circuits, let me do it again. Okay, so this one is the first resistor, this is the second resistor, and this is the third resistor, which can be connected here. This is, let's say this is A, this is B, and this is C. So in order to find the values of A, B and C, we have a formula that the value of A can be found out by adding all the resistors which are connected in a delta configurations, and these resistors are 100 plus 125 plus 25. These are all the resistors which will be in the denominator, and in order to find the numerator, we have to look for all the resistors which are connected with this point. So there are only two resistors connected with this junction, and these resistors are 100 and 125. So we have to multiply them together. So when we will multiply them, it will become 12,500 divided by adding them, we will get 250. So after finding the equivalent resistance, we will get 50 ohm here. Similarly for B, the denominator will remain the same by adding all the three resistors, which is now again 250. But now for B, the two resistors which are connected with this junction are 25 and 100. So this 25 and multiplied by 100, these two will cancel out, it will again cancel out, and at the end we will get 10 ohm. Similarly for finding the value of C, what we will have, the value of C will be again the denominator will be 250 ohm, and numerator for this one will be 25 multiplied by 125. So simplifying it, 125, this 2 into 25, this will give me 12.5 ohm. Okay, so these are basically the three resistors which we have find out the values. So putting them here and then simplifying the circuits just by removing these resistors. Let me remove these resistors here. So this resistor will be removed. Well, let me remove this resistor and then this resistor. So the equivalent circuit will become like, you can see that here we will have here we will have this circuit, which is basically this series circuit, and A and 5 are in series, while this circuit, which is basically the series combination of resistor B and 40, these are again in series, while C and 37.5 are again in series, and the configuration of these two are basically in parallel. So converting them into some unambiguous form, it will become like this one. Okay, so here this is 5 ohm resistor, the resistor A is 50 ohm. Similarly, the value of resistor B is 10 ohm, and the resistor here is 40. The resistor here now we have find out is 12.5, which is the value of resistor C, and similarly this is 37.5. so the equivalent resistance is, okay, this one, this is here, and here this one, this one, these two are now in parallel, and the adding them together, because now these two are in series, these two are in series, and these two are again in series. And in series we know that to find the equivalent resistance, the individual resistances are added. So here it will become 50 ohm, it again becomes 50 ohm, this is now 50, and this is 5 ohm. Okay, so let me go down. Let me go down here and solving it here. So now here we can see that this, now this circuit has become this, and equivalent of 50 to the R50 is equal to 1 over 50 plus 1 over 50, as the two resistors are in parallel. So the R50 will be equal to 25 ohm, because two are in parallel, so their combination will be half of any of them. Okay, so now this is our circuit in which this is 40 volts, and this is 5 ohm, this is 50 ohm, and this one is 25, and at the end, by now these three are in series, so in series configuration, adding them together, we will get here 80 ohm, and this is here now 40 volts. Okay, so this is now our equivalent circuit, where 80 ohm is our equivalent resistance. So now here we can easily find out the value of current which is flowing or provided by the 40 volt source. So that is basically, we can find it out by using the Ohm's law. So I is equal to V by R. V is 40 divided by 80, so it is now 0.5 amperes. Okay, so this is the current which is provided by the source. Similarly, the power provided by the 40 volt source is equal to I40 multiplied by 40, which is P is equal to IV. So by using the values here, 0.5 multiplied by 40, so this is now 20 watts. Okay, so this is the overall circuit, and the actual consideration behind solving the circuit like this one is to see that what are the configurations which are neither series nor in parallel combinations, and how to solve the circuits like those ones. So initially we have to find the equivalent resistance, pick any of the two deltas, or pick any one of the two deltas, or any of the stars, and convert them into the other configuration, and you will see that is basically our circuit. And here we have used the conventional circuit laws to find out the equivalent resistance, and after finding the equivalent resistance we find out the current and power supplied by the 40-volt source. So that's it for today, and we will solve more questions like this one in our upcoming videos. So thank you so much, and I'll see you soon.